Welcome to our third lesson in the series, Applications for Completing the Square. So this is the third video in completing the square. So if you're not familiar with completing the square, you might want to stop here and go back and watch parts A and B, because I'm assuming in this lesson that you have previous knowledge to completing the square. So first things first, completing the square is an awesome method to convert your quadratic function that's in standard form to vertex form. So once you understand completing the square, it can within minutes tell you so much about your quadratic function to answer pretty much any question that anyone would ever ask of you about a quadratic function, whether just a quadratic function in general or relative to a real-world problem. So let's dig in. So this is the vertex form of a quadratic equation where the value of h and k is the vertex. Reminding you that the formula here is x subtract the x coordinate of the vertex, this value h. So we'll review this, but if it's x add h, then h is negative. So the formula is x subtract the x coordinate. Okay, so this subtraction right here does not make h negative. H is positive in this instance. Whereas with the y coordinate of your vertex k, this addition symbol makes this positive. If this were subtract k, then k, the y coordinate, would be negative. So we can use the method of completing the square to write the quadratic function in vertex form from standard form. So if you're given standard form, you can go from standard form to vertex form. Why would you want to do this? Because the method of completing the square will find the solutions to any quadratic equation, while also finding the vertex of the parabola. Thus, you can graph the parabola, determine the vertex, which is also determining whether it's a maximum or a minimum, and find solutions all at the same time. And I'll also note that when it's in standard form, you know the y-intercept. So after a few minutes of spending time completing the square, you'll know the y-intercept, the roots or the two x-intercepts, or if there's one x-intercept or none, and you'll know the vertex. So very helpful in having you graph the quadratic function. So let's go ahead and try one. So you begin, and we're going to cover one when the vertex, finding the vertex when a is 1. Okay, and then we'll cover some when a is something other than 1, reminding you that -1 is not 1. So we'll begin, and we're going to stop before finding the square root of both sides. Okay, so that's the caveat here. So we start the process by setting it equal to 0, which is the zero product property, and we use that to find the roots or the x-intercepts. We're going to subtract 10 from both sides. Half of 8 is 4. 4 squared is 16. So we've created our perfect square trinomial here. Because we've added 16 to this side, we must also add 16 to the right side. Write this as your perfect square, x plus 4 squared, and -10 plus 16 is 6. So here's where you stop. Normally, you would go and find the square root of both sides. We're going to stop here, noticing some similarities. Subtract 6 from both sides. Now we have vertex form. We can go back and undo the zero product property and put our y back in. So here we have vertex form. Standard form, vertex form. So I know that the y-intercept is 10, and I know that the vertex is -4, -6. Now, I'm going to go back up here, and I'm going to say, finish completing the square. So here's where I stopped, and I'm going to go back over here and say the square root of both sides. So x plus 4 equals positive and negative 2.45, because the square root of 6 is positive and negative 2.45. Subtract 4 from both sides, getting me my two roots of -6 and 45/100ths and -1 and 55/100ths. Noting again, I always round to the nearest hundredth. All right, so now I know my roots, I know my vertex, and I know my y-intercept. So let's go ahead and look at a graph. So we started off with standard form. We immediately know our y-intercept. Here's it in vertex form. Vertex, -4, -6, and my 2 roots. All from completing the square. Okay, so here we go. This is what we're going to do when we're finding the vertex using completing the square when a does not equal 1. So here we have -1. Now there's 2 ways of doing this. And I'll mention, I'll do one, I prefer one, and then I'll mention what the other one could be. So here we go, noting that the value of a is -1, we are going to set it equal to 0. That's what we're going to do when we're going to find the roots and completing the square. The whole idea is to finding the solutions or the roots. I divided every term by -1. In order to complete the square, the value of a has to be 1. Some people, our teachers, students, whatever, whoever, all alike, we have, put, right here, sorry, grabbing my pen, put parentheses here and pull the -1 out. All right, and then they complete the square for what's inside, keeping this -1 here all along, okay? I prefer just to divide everything by -1, and then remember that when I go back in after, that I have to come back at the end and put this in. So I'll cover it that way. So complete the square, subtract 20 from both sides. Start to create our perfect square trinomial. Half of 14 is 7. 7 squared is 49. Add 49 to both sides. Write it as your perfect square trinomial. X plus 7 squared equals 29. -20 plus 49 is 29. So this is where we stop and subtract 29 from each side. Here's where you have to pay attention. When you put your y back in here, we have to consider that a is -1. Because we divided every term up here by -1, we now must go back and multiply every term by -1. So we're going to have negative, this is one term, this is a product, but it's one term. So negative times x plus 7 squared, and then negative times 1 times -29 is positive 29. This right here is where students will make the error, forgetting to put the a back in there, okay? So we have our vertex. This will be -7 because it's add 7, so it would be subtract -7, giving me an x-coordinate of -7, and my y-coordinate is positive 29. Noticing if you left it here, something would seem awry because it wouldn't work out when you went to graph it and checked it. Now let's go back over to here. Completing the square, we're going to finish finding the square root of both sides, and then subtract 7 from both sides, giving us our roots. Okay, now let's look at this on a graph to make sure it all makes sense. That's what the graph does. It visualizes and does all my solutions make sense. So I started off with this in standard form, and I can immediately see that my y-intercept is -20. I notice too that it opens down, and it should. It's a reflection in the x-axis. Written in vertex form, -7, positive 29 is my vertex, and then my 2 roots. And on this graph, they happen to be rounded to the nearest thousandth, but it works for us. It's approximate. So if you're graphing it, of course, you're not going to graph -12.385, but you know that your roots are between -12 and -13, and over here you know that it's between -1 and -2. So it gives you an approximation. All right, your turn. I would like you to use the method of completing the square to write this in vertex form to find the vertex and the solutions or the x-intercepts. And I would like you also to sketch a graph of the parabola. So go ahead and pause and come back and hit play when you're ready to check your work. Welcome back. Noting here that a is not 1, so we set it equal to 0 to find the x-intercepts. I'm going to divide everything by 2, and now I have this. Noting you could put parentheses here and just have factored 2 out. Okay, and then left it there and multiplied back in. I like to take it out and put it back at the end. So half of, over here I've gone already and added the 3.5 to both sides and found half of 8, which is 4, squared is 16, and added 16 to both sides. Write it as your perfect square trinomial. Combine like terms. Subtract 19.5 from both sides. Remember to put a back in, and now I need to distribute it. So it becomes y equals 2 times this product, and then 2 multiplied by negative 19.5 is negative 39, giving me a vertex of negative 4, negative 39. Come back and finish completing the square, finding the square root of both sides, subtract 4 from both sides, and there are my roots. So I know my y-intercept, I know my vertex, and I know my roots. Let's visualize this. So here it is in standard form. Graph your y-intercept. Here it is in vertex form. Graph your vertex, and then graph your roots. And there you have it. Also want to note, reminding you that this is the minimum value in the function. So all parabolas have a minimum or a maximum value. If they open up, the vertex, the y-coordinate of the vertex, negative 39, is the minimum value. So the minimum value here is negative 39. All right, real world problem. We have a wading pool, and it's 1 foot deep. It has a volume of 133 cubic feet, and the width is 12 feet less than the length. So I'd like you to write an equation that represents the volume of the wading pool. First, reminding you that volume is equal to length times width times height. So 133 is the volume, and that's equal to the length of x, the width of x minus 12, and the height or the depth, which is 1. So we're going to use this to find the dimensions of the wading pool by completing the square. So first you're going to multiply just x times x minus 12, and then anything times 1 is itself. So here we have it, and it's almost already set up for completing the square because we have our c value of our quadratic function already on the left here. So half of negative 12 is negative 6. Negative 6 squared is 36. So you can see I've added 36 to both sides, giving me 169 on the left equals my perfect square trinomial, x minus 6 squared. Square root of both sides, positive and negative 13 equals x minus 6. Add 6 to both sides, and you get the roots of 19 and negative 7. Because this is a real-world problem, this is an extraneous root that we don't need because we know that the length cannot be a negative value, and x is equal to my length. So we know that the length is now 19 feet. So our length is 19 feet. Our width, which was 12 feet less than the length, is 7 feet, and we were given that the depth was 1 foot. So there you have it, that wading pool, completing the square. All right, thank you for joining me today. I hope you enjoyed the lesson. Go ahead and subscribe to the channel if you'd like to see more, and go ahead and give me a like or thumbs up if you enjoyed the lesson. Have a good day.